hvis den bare holder øje med din hangout, du kører nu.
Okay. Thank you. So I'm going to present to you a short presentation on DevOps, actually going behind DevOps, the buzzword, and what it really all means. I'm going to introduce a few new terms to you. Continuous delivery. Well, they're not new, but it relates to DevOps. We're going to talk a little bit about lean and agile. So I am Lars Kruse. I'm partner in Pragma, a consultancy bureau. What we do is that we do consulting in Scandinavia, in Denmark, Norway, and Sweden. We do dev, test, and ops. So anything related to this is our business. And we do a lot of training, specifically in all the tools that are usually utilized in the tool stack that implements dev, test, and ops. So that is what we do. We have 8 offices in 3 countries. As I said, Denmark, Norway, and Sweden. We're 47 people. We are more diverse than Lower Manhattan. We have 19 nationalities. We only have 3 printers, but we do drink a lot of coffee. And we are heavily engaged in both GitHub and Slack channels. So that is how we communicate when we are distributed as we are. Besides our business, we are running a lot of initiatives, specifically 3. Codeconf.com is where we present all our conference stuff. We have an initiative called Code Academy, where we once every August we teach students at the colleges and universities throughout Scandinavia continuous delivery. So it's 4 days intense training where we teach them Docker, Jenkins, Agile training, Artifactory, stuff like that. Things that are needed in order to learn the ropes and work the continuous delivery and DevOps landscape. And we have an alliance, a group where we meet every half year with some of our more advanced and ambitious customers, where we work together, develop different kinds of open source tools that can be used in this setup. Anything from Jenkins plugins, Git extensions, Gradle plugins, Docker containers, everything that we're doing together. A large community, actually, with a lot of companies meeting up 2 days every half year, hosted by one of the members. So that's us. Now, let's get back to DevOps. What is DevOps? Everyone is talking about it, really, but where does it come from? Well, it is a contraction of the word dev and ops, obviously, but and that refers to the fact that devs and ops historically have a problem being in the same room. They're not necessarily best friends. You could say that it's a common feature that software developers are supposed to develop software. At some point, somebody else is supposed to take over and throw it over the fence, like this short video. There's no audio in it. It's actually a CCTV camera. Let's say that this FedEx guy here, he represents the software developer. He got a piece of software to deliver. It's actually a computer monitor, but the analogy is good. There you go, delivered. I'm off. On the other side of this fence lives the ops people. Now they're supposed to pick up this package, whatever it is. It might even be broken at this point, but they're supposed to put it into production. So for a lot of companies, this is actually how it works. And obviously, devs and ops needs to be closer to each other. So you might say that dev and ops is about breaking down silos, breaking down fences, and bringing both devs and ops into the team. What's interesting is that if we look at ops from a modern perspective, maybe not modern, but how we usually see at it, at ops, you say, what do we get from ops? And we get a lot of things from them. We get infrastructure, performance, sizing, provisioning, We got user management. We got all the iron running, all the metal in the basement, quality gateways, and deployment. We got a lot of stuff from ops that are actually really useful. But the thing is that it's also a switchover. It's a handover. Some people did something. Now new people are supposed to do something else. So in a DevOps environment, where you have a DevOps mindset, you want to put all the resources that are required to put your product into the hands of the end users into the same team. So you might say, what do we really want from ops, seen from the perspective of the development team? And a lot of these things are actually things that we would rather have in our own team instead of handing it over to somebody who's going to take it over. The deployment, well, that's us. We need to do it a lot of times because we need to do a lot of testing. The sizing, I mean, if we were in a real good, well-dimensioned environment, it wouldn't be a problem. But otherwise, if we weren't, we could just go and say Control+++, and we would have a bigger, faster, more environment. And if we don't need it, we could downscale it again. These are just features, right? So essentially, the only thing that we need from ops is all the metal in the basement. Other than that, we would actually like to do the rest ourselves as a team. And you might even say that we don't even need that, we need the cloud. So somewhere out there, we need access to machinery that can support us. So if we get that, then we can have the ops people joining the team with all their technology and all their knowledge and all their skills. They can join the team and essentially become part of the team and help us continuously developing what we want to develop. Now, the way this works is that everything becomes code. Software is eating the world, right? So everything literally becomes code. What we want to do is that we want to turn configuration, infrastructure, test, essentially anything that you want to do, marketing, your lunch, everything becomes code so that it can be version controlled, it can be syntactically checked, it can be executed, immutable, so that next time you execute the same piece of code, you get the same piece of result. This is really interesting perspective on the way we want to work, because this way we also get a lot of documentation for free. If we accept that code is documentation. If something is programmed, you don't have to put that bit of information on a wiki or something, because you can just go and read the code and see what the code does. So this is also a way of capturing what people know. Actually, instead of writing it in a Word document, write it as code. We can execute it. I want to take you down memory lane just for a short moment here. So I don't know if you know this picture. It's an old picture, right? Depends on how old you are. I'm old. I'm almost 50 years old. I remember this picture. It's the whale diagram from the rational unified process. This is actually something that we believed in like 20 years ago, 25 years ago, that this is gonna save us, right? Iterative and incremental processes is really gonna save us. Instead of having one big waterfall, what we're gonna do is that we're gonna create a lot of small waterfalls instead. And that's gonna help us. So we do iterative and incremental software development. Well, it turned out that actually didn't do a lot of difference to a software development process. We were equally late and we delivered equally bad software with still quality needed to be glued on instead of built into the process. So Agile came along and said, it's actually not small waterfalls. It's more like a humdrum or a hamster wheel, right? Everything is like a flow. You just continue inside this approach. If we lay it out like this, you might say that iterative and incremental, that is a project that consists of phases, right? Could be development, integration, test, deployment, release. Whereas in Agile, what we say is that we don't know what you want to do, what the phases are. It's not really important if you can read the small nitty-gritty letters in there, because whatever you want to do is what you want to do all the time. So every time you do a release, you do everything again, right? So basically, there are no phases when you do Agile software development. It's only a flow. That actually, that's an important point that we'll revisit in just a second. I just want to see if you understand the concept of water guile and Agile fall. what this means is this is most nowadays software development teams actually potentially working in something that could be described as waterfall or agile fall. Essentially, in the development process, you all get it, right? It looks iterative, it looks agile, but then when you want to release, you come back to throwing stuff over the walls or not really having testers in the team. That's a department you hand over to. The deployment, that's another department. Release is done by release people. So now you have phases again. Now you just have small waterfalls. So even if we say that we're agile, right? So we're doing stand-ups and we're doing agile planning and all that, but in the end, it really looks more like iterative and incremental software development. And we need to get away from that. Going even further back in memory lane. So agile comes from lean. So essentially, some people believe that instead of trying to build software, building houses and bridges, we should try to build software the same way that the automotive industry was trying to optimize the Japanese factory floors using lean. Toyota Production System, Six Sigma, it really caught on with the entire world. And they have some very easy to understand principles. We want to eliminate waste. We want to amplify learning. We want to decide as late as possible. We want to deliver as fast as possible. We want to empower the team and build integrity in. And we want to have a holistic view and see the whole, right? This is lean, but it's also agile. So agile comes from this, right? And it's very important to understand that if we look at it like this, then software becomes like a factory. So because now it's not a construction work like building a skyscraper. Now it's more like, how do I design a process on my factory floor? This is an early picture of the Ford factories, where you can see that this is one of the first concepts of an assembly belt. Even if it's not moving, the teams are moving, right? So in the front, you mount the mirrors, and after that, you mount the engine, and after that, you mount the gearbox, and after that, you mount the seats, and at the end, you're done. Right? So imagine that we're doing software. Then this is 2018, and now cars have software in them. So what we're going to do is that we're going to clear a couple of square meters in the back of the assembly hall here, and then we're going to set the software developers down there. And when the car reaches the back of the hall, we're going to flash the car with software. What we call that is water scrum fall. What it refers to is that we can have agile processes while doing software, but the rest of the world is actually still doing waterfall. So we need to tap into that. It puts a lot of demand on software developers, because what we're supposed to do really is that we're supposed to deliver the features that we promised with the quality that we promised on time and within budget. That is what is expected of us. And that is what the rest of the world is doing, right? And that is what we need to tap into. Especially if software is eating the world, and software needs to go everywhere, in medical devices, in cars, in the price tags, in the supermarkets, in my goggles, everywhere you put software. And these are not, computer programs running on your app or your smartphone. So they're part of a bigger production process. So we need to tap into that. It's very important. If we want to learn more about lean and how it works in software development, we could go back to this couple. Who are they? They're Mary and Tom Pomdick. They released a book almost 20 years ago that's called Lean Software Development. And you want to read this. This is essentially a software development Bible, right? It's very important to understand these principles. They are the foundation of Agile, what we're working on. At this point, usually I show a short video, but at this point, I'll just explain it. I was talking about the Andon cord. The Andon cord is a system that empowers a team member at a factory plant to stop the line, so a defect cannot be passed on to the next process on the assembly belt. This is something that Toyota invented. It's literally a cord that runs throughout the entire factory assembly belt. And any worker, any blue-collar worker, can at any point in time pull the Andon, and the effect of that is that they essentially stop the entire factory. At least they call for help, if the help cannot be applied until the assembly belt, before the assembly belt moves, then the assembly belt will not actually move before it's fixed. And this is actually pulled, this andon cord is pulled by the workers at the assembly belt a lot of times every single day, hundreds, maybe even thousands, depending on the size of the plant. But it's very important that if you want to empower people and then you have to be strong and committed enough to follow your rules. You can't come up running at somebody pulling the andon cord and saying, hey, what are you doing? You're stopping the entire factory. Stop doing that. You need to believe that if building in quality is something that you really, really want, if the right mirror is part of the definition of an Avensis, Toyota Avensis, then you need to mount it. And if you don't have any more bright mirrors in your short stock, then you're supposed to pull the andon and say, I can't deliver what I'm expected to do, right? This is referring back to the water scrum, right? We need to deliver the quality that we promised on time, on budget. And if we can't, then we can't deliver anything, right? So this is how the factory floor looks like if you're doing software. So up in the right corner up here, you have something coming in. It's a task, it's an issue, right? Some software developer needs to do that. So one of you will take this and start hacking on it. Hackety, hackety, hack. Now it works on your computer. That's really, really cool. But the problem is that that's not where it's supposed to work. It's supposed to work on in the hands of the end users. How do you know that it works in the hands of the end users? Well, there are a lot of things that we need to do in order to test that, right? So first of all, we want help to do this. So we acquire a robot. This robot in these pictures could be Jenkins, or a Travis CI, or Bamboo, or a Circle CI, or a Concourse. This is typically what we refer to as the CI system, but it could also be a combination of different robots. It could also be a deployment platform, or some test automation tool, or whatever. But the whole point is that as soon as we're done with it, from our perspective as software developers, we put it in a version control system, and then we push it to somewhere else, indicating that we're done, right? I believe that I'm done. And then the robot takes over. The first thing it does, the gray area in this picture, is what we could refer to as the continuous integration process. The orange area in the picture could be referred to as the continuous delivery process, or the pipeline. But let's go through it. The integration basically means whatever you have on your development branch right now, can we merge that into the master without any conflicts? Yes or no? Is it integratable? Okay, then we do that. The robot will do that. Once we have that, we will do the build. And you might say that the build here is actually in quotation marks, because we're not just compiling and seeing that it works. We're also running all our unit tests. So we're testing it syntactically, we're testing it semantically, and we're testing all the things that we can do relatively fast. And the faster we can go, the more we can put in here. The first part of this loop, the gray loop, needs to finish relatively fast. So it's very important that the software developer gets a fast feedback. We're talking minutes here, right? So if you have a long running end-to-end test, you don't want to put it in the gray area, because that prevents you from getting a fast feedback. So you want to put that later in the orange area. Fast feedback is really important here. So once we're there, we'll end up with a tollgate pass. So the gray process up here will put it into the master branch. So at this point, the code that was originally developed on a task branch or an activity branch is now on the master branch. So the question is it really supposed to be there? I mean, can we verify it? And what we do is that we do a lot of analysis and metrics, all kinds of analysis and metrics, to make sure that we get numbers and metrics about our code to see how much, what is the level of technical depth in our code base. You can test for cyclomatic complexity, or if anybody have commented out code in there, or if anybody left, to-dos or in the comment fields, or whatever. Anything that you could potentially think of, copy and paste reuse, wrong use of patterns, anything that you could think of, you can analyze that. This is static analysis, and it usually runs relatively fast. potentially you can run this in parallel and even put it in the gray area. But you'll get numbers about your code. Are we okay-ish? And if you're not, then it's a threshold, and then you just go and say, no, we're not okay, and then you go back and say, please, improve your code. We're not where we want to be. Next thing is that we want to deploy it. Deployment means that we need a production-like environment. So we need to take it from where it currently is to where it's supposed to be. The deployment requires a production-like environment. Do we have them? If not, then we need to create them. This is where Docker containers and orchestration frameworks come into play, because we need a lot of production-like environment. Actually, every software developer needs a new production-like environment every time he needs to deliver something. So that is a lot. So we probably need some kind of virtual or Dockerized technology in order to be able to do this. But let's assume that we have now access to production-like environment. Then we need to deploy it, whatever that means, right? Updating databases, updating data, deploying binaries, whatever we need to do needs to be done, right? And this is an automated process. No hands, no human hands are involved here, right? Because we need to be able to do this as part of a documented process, so documented that it's actually immutable. And if that is really what we want, then we need to write it as code. So the deployment process is also code. At this point, next step, now we have deployed to a production-like environment. That gives us a lot of benefit. Now we can do functional testing. We can do functional regression testing. We can do end-to-end testing. We can do all kinds of tests, right? And we're going to do that. So it means that we will program all our tests. No manual tests, no Word documents. We will program everything and run that. Next thing we do is that we need to create a lot of documentation. Obviously, the end user documentation, we can't put this in here because that requires technical writers actually, writing nice prose. But there's a lot of documentation that we can create from this process, because now everything is linked and traced to each other. So release notes, bill of materials, all that kind of documentation that is required to making a release package, that can actually be retrieved 100% automatically, because we can just trace back through all the systems that was used so far and document it. Throw it into, I don't know, a PDF document or a database or whatever, but we can get that information, and we should do it automatically. At this point, if there's any validation that we need to do, which basically in this context means that if human needs to look at it and validate it before it's handed over to end users, then now is the time, not before. So you would not go up here and have a validation process that would be like a peer review. Because peer reviews are validation, and validations are done when we have had the robot do all the things that the robot is capable of doing. I don't want to waste my colleagues' time doing a peer review if it turns out that the functional test is going to fail anyway. So I want to run the functional test. Otherwise, it doesn't make sense to bother with my colleagues' time and effort. So that's why we put validation, human validation, in the end. So this is the factory floor. Now we have a potential shippable increment, and we're gonna take that to the market. You can say like this, that we can add a few steps to this drawing. We can say we need to transport it to wherever it needs to run. So apparently this piece of software is something that runs in a factory, but this is kind of the deployment into production environment. And if we have something like this, it's interesting to look at it and say, what happens if we split this up in lead times? The time it takes from you start coding on something and until you're done in your process, the time from you push and until you get a feedback or it's on the master branch, the time from it enters into the master branch and until you know if it's actually a potential shippable increment because it has the quality that you want, and the time it takes you from get it from where it now is part of your stock and into the hands of the end users. It can be really helpful. These are some of the things that I asked you about in the query. I won't go into much details in the query I asked you because not a lot of you actually answered it. So it doesn't make sense. We don't quite have data enough to look at that yet. But it could be interesting actually to go and analyze what are the numbers here in your setup, in your pipeline, in your value stream. Because if you know these numbers today, then it's interesting to go and measure half a year from now and say, what do they look like in half a year? Because you want to improve these lead times, right? The time it takes to travel through the value stream is really the only thing that's important. Looking at that, we might actually ask you back in the agile context, how long are your sprints? Right? Say that your sprints are 2 weeks. It's very typical that a sprint is 2 weeks. But ask yourself, are they longer than a full cycle in the value stream? So what if the process going through the entire value stream, it takes you a couple of days to develop something, then your automated build, that takes maybe a few minutes or even not some kind of insignificant amount of time, but then your verification process, that might run for days or weeks, right? So the point is that very often we see that just one cycle in the value stream takes more than a sprint. It might take a month or two. And this is where Agile completely does not make sense, because you're supposed to be able to work without phases. And I can't see how you can work without phases as if it was a flow if your sprints are shorter than a cycle in your value stream. Anyway, that was kind of my pitch to you. I just have a small animated story. So just one more minute. 2. Imagine, I want to argue that the task sizes, the things that you work on, needs to be small. And the reason why we argue that is, again, it's picked up from Lean. Imagine that we have a process consists of 4 individual processes: develop, verify, validate, release, and then we have something. Now imagine that we need to implement, let's say, 4 features. And we can do it like this. We can develop, then we can verify, then we can validate, and then we can release. This approach represents a large batch size. It could be a long sprint or it could be long tasks. Now, if we want to do it a more agile flow approach way, is that whatever you pick up, you finish that, then you pick up something else, then you finish that, then you pick up something else, then you finish that. If everything goes well, you end up in the same situation, that you end up releasing everything in the hand of the end users at the same time. It will come in drops or drips if you do agile, and it will come as a huge delivery when you do a huge batch. But let's see what happens if we introduce just one tiny defect into this approach. So at this point at validation, it turns out that something was wrong. So the software development actually doesn't work. So now we need to do the software development again, and we need to do the verification again. And then at this point, we're now done. So now we can deliver. If we introduce the same tiny defect down here, so then I need to redo my development and my verification, and then I can continue. So it's actually, in the long run, much faster to deliver small batches. You can say, what happens if you deliver 2 tiny defects? So the first defect here is the same that you saw already. So once we're done with that, let's introduce a new defect that comes in later. At this point, you again have to do all the software development again, and all the verification, and all the validation. The same 2 tiny defects introduced in a flow that has small batches, like shorter sprints, shorter task sizes, actually enables you to fix whatever you want to do relatively fast. So you're still kind of a tryout period, but once you're done with that, you can actually deliver quite fast. So you can imagine yourself what happens if we introduce 16 tiny defects. Or I don't know how many tiny defects you have in a 2-week sprints, but it might be 50 or 100. But you can see that it's really slowing you down, that your batch sizes are too big. So maybe try to run 1-week sprints or 2-day sprints, or even try to develop whatever you want to develop using Kanban instead of a Scrum approach. That was it. That was my pitch to you. So I don't have anything else except questions, if you have any. You can add them to the chat.
Skal du bare ind på... Nå, her, okay. Her.
Mm. Okay. I got a message from Tanya saying thanks. So if you don't have any questions, you want to type in the. Okay, now we get a few comments. Very good. Perfect. Glad that you liked it. I have a ton of stuff, but this was what we could do in 15 minutes. Okay, just a second. We're waiting. Just a second. There is a question. Good. Okay. Okay, so the question that I got up here is what kind of workarounds you have used to emulate production environment with lots of integrations and users with Docker, it says. But yes, okay, we can't really emulate users, but actually what we can essentially emulate anything, right? You can have, but you. Yeah, I'm then getting more here. I don't know what so it says you can't emulate users and integrations are only available in production environments. But what you want to do is that this is essentially what you do in an emulator, right? So you need a production-like environment. So in the production environment, it's true that the only thing that you have is the real thing. You have the real users, and then you have the real the real integrations. But in your production-like environment, what you want to do is that you want to test in a production-like environment. So whatever your integration is, you need to be able to exactly emulate them in your production environment. So you need to come up with some kind of way where you can actually fake a lot of users. So you need to create volume, or you need to record something from your live production environment that can represent a lot of volume, or the integrations that you maybe don't have, you will have to get them there one way or the other. So by emulation, and if you don't have that, then essentially you can't test anything before you get to your production environment. This is like in the embedded world, what you would do is that you would obviously have your software development run on some kind of device. But until you get to that device, it might be a really expensive device. It might not even be built yet because it's on its way from, the chips are still on its way from Asia, and you only have a few, lab boards or whatever. But what you want to do then is that you want to build an emulator that can emulate all the things that you need from your environment. And not doing that essentially means that you are not testing anything before you reach the production environment. This is not where you want to test your stuff. I'll send you these as posters, right? So I have a few posters. I'll send them. I'll make sure that you get them. This maturity model here is something that we use to have a chat with people and companies about how they're doing. So it's not really a maturity model in the sense that you're supposed to score, like say that you have 70 out of 100 points. But what it can do is that we can use this to talk about how do we improve the different areas that are relevant to our value stream. And we have a lot of the the testing and the production-like environment are available here in DevOps, in testing. I don't know if I answered the question that I got, because the question, how do I work around the emulating all these things? But the whole point, the question is that you don't emulate it. You actually do want to emulate, or you don't work around it. You actually do it, right? And obviously Docker is the right way to go, because that is the way that you can, the cheapest possible way, emulate a production-like environment. At this point, I'm done. So let me know in notes if you're okay with this, or if there's anything more. I got a thumbs up. Good. Yeah, thumbs up. Yeah. So suck it up. Just do it. Right. There's no easy workaround. It's just hard work. Good. All is good. No more question. It's a wrap up. Okay. Thanks for listening. Yeah. Good. I got one more.
Coming up.
Okay, what measurements and points would I recommend to use in development CI? First, is it for first feedback to developer, or? Yes, so if we go back to the, I think the question is about this slide here, I would imagine, talking about the first feedback up there, not that one, the development lead time, but potentially this one. What is the first feedback that you get? Is that correct? Is that what we're talking about? Yes. Okay. So so the feedback that we need here is essentially something that I need some kind of a thumbs up, right? So these are all the blue dots, or if you're using the plugin that turns your blue dots in Jenkins into green ones, or if you're using Travis or Bamboo or whatever. But essentially, this is a successful build, right? So whatever it means, and we call them builds, but really they're jobs, because they're not building, right? It might be integrating, it might be doing technical static analysis, but this is the feedback that I want. What we have done in Pragma is that we have created a handful of Slack channels for different setups where all this noise goes in. So we don't spam people with emails, but we make all this available information available in our chat rooms. We use Slack. So this information is just poured in there. So when I do something, if I commit something to my pipeline, I will be looking for the first feedback popping up in my Slack channel within a minute or two. So the first feedback should really be fast, typically as fast as you would expect it to occur if you were doing it on your own computer. So if you were on your own computer and you would do the build process and you would run your unit test, then you would expect that to return in the time it takes to literally compile and run your unit test. Maybe that's 2 minutes. So I would expect my infrastructure to be able to accommodate that and return also in 2 minutes, because I can do it in 2 minutes on my computer. So any Bamboo agent would also supposedly be able to do it in 2 minutes. And this is where I don't want it to take 30 minutes or 15 minutes or 2 days, right? Because every single commit we do, we need to get the feedback. So we need to get the feedback from the entire pipeline. So it needs to run a lot, but I can't wait for a feedback that potentially runs for 3 hours, right? So that's why we have actually split it up in a gray area and an orange area. I believe that if we revisit a slide like this in 5 years from now, and we have become really, really good at implementing continuous delivery and DevOps, then I would say a lot of the things that are actually currently put into the orange part of the picture are things that are there because it takes a while to execute them. But if we could execute them in seconds, right? Let's say that I could fire up a production-like environment and deploy, and each of those would take a couple of minutes, and then I could run all my functional regression tests. I could run them maybe in 15 parallel suites, and they would all run in less than 2 minutes, right? If I could do that, then the only thing I needed in order to be able to finish and prepare the feedback in 2 minutes, that would be more resources. And at this point, I hope that everyone knows that the resources we're talking about, they're just essentially instances in the cloud. They're Docker containers firing up, running, shutting down, right? So if I could, for each commit that I do, fire up, I don't know, 50 Docker containers that could run in parallel and do whatever I want to do, and if they could all finish in 2 or 3 minutes, then there's no reason why I wouldn't do all of it, right? The problem is that most of us can't do that in a couple of minutes right now. But maybe in 5 years, that more and more of the pieces that are currently in the orange area will go up into the gray area and really deliver a really, really fast feedback to the software developer every time he commits to his version control system. That's the ideal situation. That was it for me. I know there is a short delay here, so where should one start such a pipeline? So I'm thinking that the first thing you're asking, what is the first thing that we do? I would recommend you to do all the things that are easy first. Building a pipeline, how do you start? I think that if you look at this maturity model and you see that we have organized in novice, beginner, intermediate, advanced, and expert, then this is not really you testing if you are an expert. These are more like signs that we see. So what we see is that if you're new and you're a beginner, then you would probably start in the left side of this matrix. But if you're really, really skilled and have been doing this for many years, then you would start having full delivery pipelines, and you would start having chaos monkeys running in your test production environment, and you would have a full audit trail in your production. So it's more like what do we usually see that people start doing when they're new and beginners, and what do we see them do later? So picking this up, I would say that essentially architecture and design code metrics, that is definitely something that I would argument that you should do early, because it's really, really easy to set up. So this is like find some kind of open source tool that can calculate your cyclomatic complexity. Scan your codes for to-dos or code that is commented out. Scan your code for count your lines of code. Count what is the average number of functions in a class. Blah blah blah. Basically, just get a lot of numbers about your code base. Static analysis. The reason why that is useful is that it can actually, I mean, not as a single measure, it's not really important. But if you do all of these measures, then together they can actually give you a pretty good picture of what is the current level of technical depth in my code base. And what you want to see is that over time, you want to see a trend, that all these numbers are going the right way, right? So the cyclomatic complexity is becoming less and less. all the things that are commented into the code base saying, oh, we need to fix this at some point, they shouldn't be there. They should be in your change management system, right? All the code that is commented out shouldn't be commented out. It should be deleted because you have a version control system like Git, right? So it shouldn't be there if it's not supposed to run, right? Then you should get rid of it so that your code becomes more readable. If you have a high level of cyclomatic complexity, then make it lower because that's probably easier to read. Test if you are using patterns and strategies. All those code metric tools, coverage from a unit test, anything really, numbers, that's good. Start with generating numbers. Next thing is that you want to do unit testing, and you want to do real unit testing. So you don't want to do functional testing and call it unit testing. You want to actually do unit testing, and you want to stop and use stops and mocks for your first level dependencies. So start doing some unit testing that will help you test the semantics of your code. You will find a lot of errors doing that. So introduce unit test, and then automate your builds. So that's essentially whatever you want to do, automate that. So focus on the things that can run fast in the gray area of the pipeline. The reason why you want to focus on the easy things first, there are a lot of things in this pipeline that are hard, but why do you want to start with the easy ones first? Simply because you are on a journey here, and you're trying to change the way that the culture and the organization around how you do software, and it's very important that you get a success while doing that. So if you pick one of the hard obstacles, say I want to maintain all my test data, and you have no idea how you want to do that, but you're picking that one because you think it's most important, and it might be, but it's really strategically not very wise to take something that's difficult, because you won't have any output. Right? So this is like the agile approach. We want to deliver continuously. And if you pick a hard topic, it will take you a month, maybe even half a year to be able to deliver anything. And what you want to do when you start to convince your colleagues and your managers that continuous delivery and automation is a good thing, then you want to show a lot of progress. That is why you want to do the easy things first. So identify your low-hanging fruits and do them. Bam, that was it. Okay, good. I in my chat here next to me, I can see that Tanya is good. We're going to wrap up. Yes. Thank you for joining us, and I hope I'll get back to you to see how this worked from your end. It's interesting to see how it worked where you're sitting. So I would like a lot of feedback on this, but I'll get back to you, Tanya. Maybe you can pick up on it and convey this information to me. Good. Let's keep in touch. Don't be a stranger. Let's be careful out there. See ya.